So we're going to be looking at the study guide for the Pythagorean quiz coming up in 8th grade. This quiz deals mainly with right triangles and the derivatives of the right triangle Pythagorean theorem formula that we derived in class. So the first part is just the basic use of using the Pythagorean theorem to find the missing side of a right triangle. And remember, the Pythagorean theorem goes like this. A squared plus b squared equals c squared. And the way a, b, and c are known is that in a right triangle, C is always the side that's directly opposite the right angle. It's called the hypotenuse. It always is the opposite the right angle, and the other two sides are called A and B. It really doesn't matter which one you call A and which one you call B, so as long as you know where C is, which again is opposite the right angle, then you're good. So you just plug in the two that you know, leave the third that you don't know as a variable, and solve for it, because you'll always know at least two of the three. You just won't know the third. Now, basically, this boils down to two methods of solving, and that is in every case you will have two numbers, like you see in number 1 and 2. You know two numbers, and you're trying to find the missing one. What you do is you either square, add, and then root. So let me write it here. You either square the numbers, then add, and then root, or you're going to square the numbers, subtract, and then root. It's always going to be one of these two pathways. The adding pathway happens when you want to find C. So when you want to find C, that's when you do this stuff here. If you need to find A or B, so to find A or B, that's when you do this stuff here. That's when you subtract. So you can either use the formula or you can just memorize these three steps here. Either way, you'll get the same answer. So let me use the formula for the first two and then the steps for the last two. So for number 1 here, I have x and then 8 and 6. So I'm going to get my formula down. A squared plus b squared equals c squared. And so 8 and 6 are my a and b. Again, it doesn't matter which one I choose as a and b, so I'm just going to write 8 squared plus 6 squared equals x squared. And then we go on through solving them. So 8 squared is 64 plus 6 squared is 36 equals x squared. Well, I know what 64 plus 36 is. That's going to be 100 equals x squared. Now, I don't want x squared. I just want x. So how do I get rid of squaring? That way I just have an x. Well, you square root it. And then whatever you do on one side, you do on the other. So you square root that. Remember, square rooting simply means what number times itself gets you this number. Well, what number times itself gets you x? Well, x, because x times x is x squared. So the way you get rid of a square is you square root it, and this square root symbol and this square symbol basically cancel each other out, and so you're just left with the x inside, which is what you want. You want to know what x is. The square root of 100, so you have to think to yourself, what number times itself is 100? Well, that'd be 10. So my answer is 10 centimeters is the length of that side. So again, I just used the formula and I plugged in the two numbers that I knew and I left the one that I didn't know as a variable and just solved for that missing variable. We can do the same thing in number 2. And now this one's a little bit twisted, so you have to figure out, okay, which one of these is my C, which one's my A, and which one's my B. Well, really just which one's my C. All I need to do is figure out which one's my C because A and B don't really matter the order you tuck them in. So if you don't know, what you can do is take your pencil, put it on the right angle mark, and draw an arrow straight across. That arrow will always point to your hypotenuse, which in this case is 0.5. So 5 is my C variable. And then that means 3 and x, or the missing one, is my A and B. So I'll say a squared, because I don't know what a is, plus 3 squared equals 5 squared. Now again, you could do 3 squared plus b squared is 5 squared. Again, it doesn't really matter which one you call a or b. I don't know what a squared is still, so I'm going to leave it as a squared. 3 squared is 9, and 5 squared is 25. Now again, my goal here is to solve for a. I want to get a by itself. So the first thing I'm going to do is move away this 9, because that's with the a, and I want a by itself, so I got to move it. So minus 9, we get a squared equals, and again, remember you do the same thing on both sides. So if you subtract 9 from one side, you have to do it to the other side. That gives me 16. Now again, I have a squared. I just want a. I want to go from here to here. I want to know, how do I get from a squared to a? Well, you square root it, because as I said, square rooting and squaring cancel each other out. Just like adding 9 and subtracting 9 cancel each other out, so they're gone, squaring and square rooting cancel each other out, so they're gone, and I just have a left. And then whatever I do on one side, I have to repeat on the other. So the square root of 16 is just 4. So 4 centimeters would be my answer there. So this is using the formula. Now, again, notice here that all we did was we squared our numbers, we subtracted, and then we square rooted. Just like here, we squared our numbers, we add them together, and then we square rooted it. So as long as you remember that process and which one goes where, then you're good. Again, you subtract when you're trying to find your A or your B, and you add when you're trying to find your C. So for number 3 here, Z is my C number, because this is my right angle, even though it doesn't show it. That's my right angle, so that means Z is my C. So I'm trying to find C. So I'm going to be using the addition method, because I know what A and B are, I need to find the hypotenuse. So I'm going to say 15 squared plus 18 squared. So I'm going to square my numbers first. So 15 squared is 225. And remember, squaring just means the number times itself. So 18 squared is just 18 times 18, which is 324. And then I'm going to add these two together, and I get 549. So I squared, I added, and then now last step is to root. So I'm going to square root 549, which you probably will need a calculator for, unless you know it off the top of your head, which you probably don't because it's a decimal, 23.43. So instead of making the actual formula, I can just say, well, I know what I'm going to have to do, so I'm just going to do that instead. I'm going to do it as a list of steps rather than an equation. But either way is fine. Now, if this 18 was switched with the z, so if the z was down here and the 18 was over there, then I'd have to subtract them. And you always subtract bigger minus smaller. But if the z was an a or a b value, then I would subtract my numbers rather than add them. But I'd still, the first step is always squaring, and the last step is always square rooting. The middle step is where it gets different. And you don't know, you can check your answer to see if it's reasonable, is that C should always be the biggest number. So Z here, which is in the C spot, 23.43. That's bigger than 15 and 18, so that's good. So that means my answer is probably pretty reasonable. Same thing for number 2. 5 is in the C spot. 4 is less than 5, which is good because the 5 should be the highest number because it's the hypotenuse. And then over here again, 10 is x, x is the C spot, and 10 is bigger than 6 and 8, so that's good because 10 should be the biggest side and 6 and 8 would be the smaller two sides. The distance formula is a derivative off of the Pythagorean theorem that's used for graphing. And what the distance formula basically tells you is how far apart 2 points on the graph are. And it's kind of a long formula, but it looks like this. You have one big square root, and what you do is you take the x1 minus x2 squared plus y1 minus y2 squared. So what you do is basically, if I were to say this in words, you take your x's and subtract them, you take your y's and subtract them, you square both numbers, you add them together, and then you square root the final product. So there's about 4 steps involved, 4 or 5 steps. Now you could also put your y's over here and your x's over here. It doesn't matter as long as you keep your y's and your x's together. So I could say y1 minus y2 squared plus x1 minus x2 squared. It's the same thing. So for number 4, let's get our big square root here. So the first thing is to subtract your x's. So my first x is 1. Remember, this is x, x, and then y, y. So 1 minus 7 squared plus 5 minus 13 squared. So the first thing you do is parentheses. So 1 minus 7 is negative 6 squared plus 5 minus 13 is negative 8 squared. Then you square the numbers. So negative 6 squared is 36. 8 squared is 64. You add them together, you get 100. And the square root of 100 is 10. So that's how far apart they are, is 10 units. So it's not a really difficult one, but it is kind of a lot of pieces that you have to keep in mind there. Let's do number 5 here. So take away your x's first. So negative 4 and 6 are my x's. So negative 4 minus 6 squared plus 1 minus 8 squared. So again, parentheses first. So negative 4 minus 6. So I lose 4 and then I lose 6 more. So it's negative 10 squared plus, and then 1 minus 8 is negative 7 squared. Then you square the numbers. So negative 10, remember this is negative 10 squared. So negative 10 times negative 10 is 100 plus, let me make the 100 a little bit better. 100 plus negative 7 times negative 7 is 49, because remember, a negative times a negative is a positive. So we add them together, you get square root of 149. That's a 4 there. So then you do just that. You take the square root of 149, and you get about 12.206, so around a 2, 1. So remember, squaring makes the number times itself. So a negative squared is going to be a positive number. So when if you're going to type in your calculator, like if you have like negative 18 squared, what you would want to type in is parentheses negative 18 squared. Do not type this in, because that will give you an incorrect answer in the calculator, because the calculator wouldn't know to square the negative along with it. So the calculator will help you out. Just make sure you plug in the correct numbers to it in the correct way, and use it only for big numbers. Like, again, negative 6 times negative 6 is 36. That's not hard to memorize, and it also eliminates this little negative trap there that you can fall into. Let's do one more here. So x is first, so 1 minus 3 squared plus 4 minus 6 squared. And again, you could do this out of order. You could do 4 minus 6 squared plus 1 minus 3 squared. That's perfectly fine as well, as long as you keep your x's and your y's together. 1 minus 3 is negative 2 squared, plus 4 minus 6 is also negative 2 squared. Negative 2 times negative 2 is 4, plus, again, 4. Whoops, not 41. So this would be, gotta get my pen here. Whoops, sorry about that. For some reason my pen wasn't going. There we go. So we get 4 plus 4 is 8. And then we have the square root of 8, which is not a nice number, so you'd have to go to your calculator to do that. So you have square root of 8, which is 2.28, so we'll round up to 2.83. So 2.828 is what I get, and 2.83 is what we're going to round to. The next ones are like the front page, just word problems. So these are right triangle problems, Pythagorean problems, just as a word problem. So two cliffs are separated by a 30-foot gap. The right cliff is 72 feet higher than the left. How long would a zip line need to be to reach one cliff to another? Well, it helps to draw a picture here. So we have two cliffs. The right cliff is higher than the left cliff. So we'll draw one cliff here, then one cliff here, a little bit higher. So it says they're separated by 30-foot gap. So right here, that's 30. And it says the right cliff is 72 feet higher than the left. So this is the point where they're equal. So that means the right foot from here to here, the right cliff is 72 feet higher. How long would a zip line need to go to reach from one to the other? So this is the zip line. We want to figure out how long will that need to be. Well, again, this is a right triangle right here. If you can picture a right angle right here, this is a right triangle. And we know the A and the B, and the zip line is basically our C value. So we want to figure out 30 squared plus 72 squared equals x squared. So again, our right triangle, 30 and 72 are my A. That missing value is my C. So I'd have this. So we're going to go ahead and do this then. So 30 times 30, which is what 30 squared is 900. Plus, and then you're going to have 72 squared, which is just 72 times 72, which is a rather big number. So 5184 equals x squared. Then you're going to add these two large numbers together, and you get 6084. Can't draw today. So you get 6084 is equal to x squared. And then again, I don't want x squared, I want x. So I'm going to square root this side. I'm going to square root this side. That way the square goes away. I'm left with x. And then again, you probably don't know what the square root of 6084 is off the top of your head. So you're going to type in the square root of 6084, and you get a nice even 78 feet. Which is good because, remember, this is my C value, so it should be bigger than the other two, and it is. Next one, again, is a word problem. We have Batman shooting a 16-foot long grappling hook to the top of a building. He's 6 feet away from the base. How tall is the building? So here's the ground. Here's the building. We'll have Batman over here. And he's firing a grappling hook to the top. So the grappling hook is 16 feet long. And it says he is 6 feet away from the base. So again, we have a right triangle here because the building is at a right angle with the ground. So we have this as my A, this as my B, and then 16 is acting as my C. So I have this. I have x squared, which is how tall the building is. I don't know how tall the building is, so I'll call it x, plus 6 squared equals 16 squared. Because again, the zip line is acting as my C value because it's on the opposite the right angle side. And so doing this, I can figure out how tall the building is. So I have x squared, 6 squared is 36, 16 squared is 256. So you're going to subtract 36 from both sides. Because again, you want to get x. So x squared is equal to 220. Now again, I don't want x squared. I just want x. So I want to get rid of the square and just leave the x. So I'm going to square root both sides. And you get x is equal to 14.832. So we'll just say 14.83 feet. And again, this is reasonable because the zip line's 16. So however tall this building is, it should be less than 16, and 14.83 is less than 16. And the last two here are basically the reverse of the front page. So in this case, we are given the three sides, and we want to say, do they make a right triangle, or do they fit into this formula? A squared plus b squared equals c squared. Do these numbers make this true? If they do, it's a right triangle. If they don't, then it's not. Now remember, the only rule here is that c is the biggest number. So in this case, 3, 4, 5, c would be on 5. So basically I'm saying, does 3 squared plus 4 squared equal 5 squared? Is that true? Well, let's see. 3 squared is 9, 4 squared is 16, 5 squared is 25, and 9 plus 16 is 25. And 25 is definitely equal to 25. That is true. So this would be a yes. They do form a right triangle because a squared plus b squared is c squared. Make that yes a little bit better. Yes. All this fits together, so this is good. What about 8? Well, again, we want to look for what's the biggest number. Well, in this case, it's the 20, so 20 is going to be my c. So I'm going to have 12 squared plus 13 squared equals 20 squared. So 20 squared I know is 400. 12 squared is 12 times 12, which is 144. Plus 13 squared, which is 169. So again, this is still 400. I want to add these two together to see if they equal out. So 144 plus 169 is going to give me 313, which is obviously not 400, so this is not true. So this would be a no. These might form a triangle, but they won't form a right triangle because they don't follow the Pythagorean theorem, which says that this should be true. So again, the Pythagorean theorem can be used as a way to check to see if triangles are right triangles by plugging in the sides you have and seeing if it works out. So that wraps up this video. Again, just remember the Pythagorean theorem and how to plug in the numbers, and especially know that C is your hypotenuse and how to find it in a picture or a diagram or a word problem. As long as you can figure out what that C is, then you should be set. Hope you enjoyed the video. Have a good